Hello students, welcome to our channel. Here we are continuing our chapter number 3, that is complex number. Today we will deal with the topic that is geometry with the complex number. Students, in the previous videos we have discussed about the modulus, definitions, basics, conjugate. There we discussed some questions also related with the topics, and in this video we will mainly discuss with the geometry. As we know that we denote a complex number in the Argand plane with the point x and y. So we can find out the distance between the complex number, we can find out the angle between the lines also, right? So here let's continue. Distance between the 2 points. If we have z1, which is x1 plus iota y1, z2 it is equals to x2 plus iota y2. These are two complex number. These two complex number with the one value that is a real part and another value that is the imaginary part. This is z1, this another one that is z2. These 2 points we consider in the Argand plane. Argand plane means we are taking them in x-axis and y-axis, right? In like we say coordinate plane बोलते हैं हम, तो coordinate plane के same as it is अगर हम क्या करते हैं complex number को जब denote करते हैं तो वो हम Argand plane बोलते हैं, right? Such that point जो हमारा complex number z1 होगा उसको हम p से denote करेंगे, right? और जो हमारा रियल पार्ट है x1 है, इमेजरी पार्ट है y1, तो यहाँ पर x कोऑर्डिनेट x1 बनेगा और y कोऑर्डिनेट बनेगा y1. Then q, which is z2, it is real part x2 and imaginary part y2. So this is x2 comma y2. Now pq, we can find out the distance between these two. It is modulus of z1 minus z2, which gives distance between p and q, right? Now here angle between two lines, which we say Coni's rule. Here A, if we denote Z1, Z2 we denote by B, Z3 by C. These all are the 3 points in the Argand plane, such that the angle between these means BAC we consider theta. So we can find out the value of theta, which is amplitude of Z3 minus Z1 divided by Z2 minus Z1, right? We subtract and then we find out the amplitude. Here we are understanding section formula. If we have PZ and this PZ divide the line joining the points A and B, then if they divide it in the ratio M ratio N, we can find out the value of P, like in 10th class we did it, right? So it can be internally or externally, right? So here we are drawing it. If this is A denoted by this Z1 denoted by A, this B here Z2, and there is a point P which is Z and divide it in the ratio M ratio N, right? So this will be M into Z2 plus N into Z1 divided by M plus N, right? So internally we can find out the values here. Externally we have P of Z equals to, we take a negative sign, this is MZ2 minus NZ1 divided by M minus N. Now midpoint formula. If MZ is the midpoint between the 2 points A and B, then we can find out the values here. Z1, this one, plus Z2 by 2. Okay. If we have here A, this is Z1, B, this is Z2, and if M is a midpoint, so what is the formula to find out M? This is Z1 plus Z2 divided by 2. Okay. Now centroid formula. Centroid of a triangle ABC with a vertex ABC, that is G of Z1. Z means जो भी हमारा centroid होगा वो क्या होगा, तीनों का sum divide by 3. Area of a triangle with the vertex ABC, this is given by half of modulus of A, right? So first of all we write down the values 1, 1, 1, then Z1, Z2, Z3. Then take the conjugate of these z1 bar, z2 bar and z3 bar. So we can derive the formula also here, right? Or the vertices, if we have z comma iota z, z plus iota z, then it is half of modulus of z square, right? Now, if omega is a cube root of unity, right? Then area of triangle with the vertices z, omega z and z plus omega z would directly learn the formula root 3 by 4 modulus of z square. Now, quadrilateral with the vertices. If we have a quadrilateral, right, with the vertex, what are the vertices given here? Z, iota z, minus z and minus iota z. Taken in order is a square with the center at origin. Origin पे center है. Now triangle with the vertex z1, z2, 1 minus iota z1 plus iota z2. अगर ये है it is a right angle isosceles, right? अगर आपके पास है ये vertices तो it is a square. This one we can say it is a right angled isosceles triangle. Now, if triangle ABC with vertices ABC is a equilateral, then we say 1 by z1 minus z2 plus 1 by z2 minus z3 plus 1 by z3 minus z1 comes equals to 0. Now, second, we can say z1 square plus z2 square plus z3 square equals to z1 z2 plus z2 z3 plus z3 z1. Now, if z2 1 minus z2 whole square we are finding plus z2 minus z3 square plus z3 minus z1 square, then sum of these equals to 0. Now, let's understand here. Triangle ABC is an equilateral. Equilateral means where all sides are same. Means AB equal to BC equal to CA. You can find out Z1 minus Z2, Z2 minus Z3 and Z3 minus Z1. Take the square of it. Let's consider K. Now, modulus square, we can separate it. That will give the same value. Z1 minus Z2 into Z1 minus Z2 conjugate is equals to same, is equal to K. Now, if we have conjugate on the both, we can separate it. Conjugate of z1 minus conjugate of z2 is equal to k into z1 minus z2. Same as we can find out the three values, right? Now here by adding we get k into 1 by z1 minus z2 plus 1 by z2 minus z3 plus 1 by z3 minus z1 equal to 0. So this is we are talking that if we have an equilateral, the sum of them is equal to 0. Now this is simplification of above results give z1 square plus z2 square plus z3 square equals to z1 z2 plus z2 z3 plus z3 z1 and the square sum is equal to 0. Now, if z1, z2, z3 are the vertices of an isosceles right angle triangle with right angle at z2, then we say z1 square plus z2 square plus z3 square equal to twice of z2 into z1 plus z3. Next is if we have to find out the equation of a straight line. Okay, so it is a bar z plus a conjugate of z plus b equals to 0, where b is a real number. Now let's understand how. If we take pq plus qy plus r equal to 0, it is a straight line, right, in a standard form. And z we consider a complex variable, then we can find x here, which is z plus z bar by 2. Okay, you can find out here how. Z bar means conjugate of z is equals to this conjugate of z equals to x minus iota y. Add to these two equations, we get here 2x equals to z plus z bar, right? And x we can find here, this is z plus z bar by 2. Okay, so this is, it is written here, y it equal to z minus z bar by 2 iota. Now we put the values, okay, plus r equal to 0. Now just simplify it. we get here p iota plus q into z plus p iota minus q into z bar plus 2 iota r equal to 0. Dividing all by iota, we get p minus iota q into z plus p plus iota q into z bar plus 2 bar equal to 0. So this we have taken a bar. Z a conjugate of z plus b equals to 0, right? So here we denote this value. Now parametric form. Parametric form, the equation of line joining the point z1 and z2 is given by, how to denote it? If we have a two lines, 2 points, complex number, and the line that is joining them, it is given by tz2 plus 1 minus t into z1, where t is a real parameter. So now understand, if P be the point on a line segment joining A and B such that P divide it into the ratio m ratio n, then Z equals to mz2 plus nz1 by m plus n. This is by section formula. If we are taking this line, this is a point, this is A, this B, and this is P, right? This Z. So we now only we studied that if they are in the ratio, right? So this is m into z2 plus n into z1 divided by m plus n. Ratio we add. So m divided by m plus n into z2 plus n divided by m plus n into z1, it is equals to. This we denoted by t and this we denote by 1 minus t. That will give the same value, right? Now, here non-parametric form. Equation of a straight line passing through the point z1 and z2 is, here we find out the determinant of it. Z conjugate of z bar 1, z1 conjugate 1, z2 conjugate and 1 equal to 0. Or you can find z minus z2 divided by conjugate of z minus conjugate of z2 bar equals to z1 minus z2 divided by conjugate of z1 minus conjugate of z2. Explanation. Line equation is the standard form. It is a bar a conjugate z plus a z bar plus b equal to 0. जो अभी हमने सीखा कि किसी भी इक्वेशन को कैसे नोट करते हैं. नाउ z1 इज ऑन द लाइन. अगर z1 इस लाइन के ऊपर है तो इट विल सेटिस्फाइड, राइट? तो जहां पर भी z होगा वहां पर क्या पुट कर देंगे? z1. नाउ z2 इज ऑन लाइन, सो पुट द वैल्यूज हियर. नाउ वी कैन सिंप्लीफाई इट, right? Also by the parametric form equation of a line joining the point z1 z2 is, we know this, and t we find z minus z2 by z1 minus z2. From here t is equal to z1 bar minus conjugate of z2 divided by conjugate of z1 minus conjugate of z2. अगर एलिमिनेशन लगाते हैं then we get these values equals to each other, right? So here we have this value which is the proof of this equation. Now let's understand the slope of a line. So if we have a and b, 2 points in the argand plane, then we say slope of line will be z1, take the values here, minus z2 divide by subtraction of conjugates, right? Conjugates का हम क्या कर देंगे? Subtraction. z1 conjugate minus z2 conjugate. तो ये आपको क्या देगा? Slope देगा. And it is denoted by w. W से इसको represent करते हैं. Parallel perpendicular conditions, if two lines w1 and w2 are parallel, तो जैसे हमने कहा कि पैरेलल में हम क्या करते हैं? स्लोप्स आर इक्वल, सेम एज इट इज. इसका स्लोप क्या है? w1 w2. तो कॉम्प्लेक्स नंबर में स्लोप इक्वल हो जाते हैं. इफ दे आर परपेंडिकुलर देन सम इक्वल टू 0. अगर सिंपल लाइन होती है तो उनका मल्टीप्लीकेशन -1 होता है. बट इफ वी आर हैविंग अ परपेंडिकुलर्स, राइट, परपेंडिकुलर्स, देन सम विल बी इक्वल टू 0. स्लोप सम इक्वल टू 0. For the line conjugate of a z plus a z bar plus b equal to 0. Complex slope is, अगर कोई भी आपके पास इक्वेशन है तो स्लोप क्या बनेगा? वहां पर क्या होता है? माइनस कोफिशिएंट ऑफ x by coefficient of y, right? So here also minus coefficient of z bar by coefficient of z, right? Now equation of a line parallel to the line this, it is, you can see here, जहां पर वैल्यू है वहां पर लैम्डा आ जाएगा, ठीक है? कांस्टेंट वैल्यू चेंज हो जाती है. इक्वेशन ऑफ लाइन परपेंडिकुलर टू द लाइन इज, हेयर वी सी जहां पर हमारा z बार है वहां पर माइनस का साइन और b की जगह क्या आ जाएगा लैम्डा आयोटा. Okay, the other values will be remain same. Length of perpendicular drawn from the point, it is here. Put the values a bar z1 plus a z1 bar plus b divided by twice of modulus of a. Now equation of a circle having center at z naught and radius r is given by modulus of z minus z naught equal to r. कोई भी इक्वेशन सर्कल की जो स्टैंडर्ड फॉर्म में होगी, राइट, तो वो क्या होगी, जैसे हमारी यहाँ पर एक्स स्क्वायर होता था, राइट, सो इट इज हियर z इंटू जेड बार प्लस ए जेड बार प्लस ए बार जेड प्लस बी इक्वल टू 0 with center at minus a and radius equals to under root of a modulus conjugate of a minus b. Now equation of circle with z1 and z2 as and of diameter, we can find out argument of this z minus z2 by z minus z1. So it is equals to plus minus 2 or z minus z2 by z minus z1 is a purely imaginary. Now consider the equation, this equal to k equal to 1. We say the locus of a point is a perpendicular bisector of line, right? If k is not equal to 1, then what do we find? That the locus of a circle is kz2 plus z1 by k plus 1 and kz2 minus z1 by k plus 1 as the and of diameter. Understand it? This will be the and of the diameter. Now equation z minus z1 modulus square plus z minus z2 modulus square equal to k. It represent a circle with k greater than equal to half of z1 minus z2 whole square. Now if we have z1 and z2 two fixed point, k is a real number such that we have taken this equation, so then the locus z is an ellipse. तो वो ellipse की formation बनती है, k की value अगर greater हो किससे, modulus of z1 minus z2 से. And if we have value of this equal to k, then locus of this is a line segment, right? Third, if we have this value k less than this, then locus is a hyperbola. Okay. If a belongs to R, then locus of z satisfying this is a parabola. ये क्या बन जाता है हमारा, एक parabolic form हो जाती है. And this will be the directrix. Now argument of z equals to alpha, where alpha lying between minus pi to pi, then locus of z is a half line. Then if argument of z minus z naught equals to alpha, right, then we say locus is a starting from A. If argument of z minus z1 by z minus z2 equal to alpha, then it represents a circular arc. So with this, we have completed the geometry of a complex number. You need to understand, you need to learn these formulas and understand it and apply in the questions. So in upcoming videos, we will deal with the questions related to this concept. Till then, take care. Bye bye.